Okay. Hello everyone. Please keep your question paper for part test number 9 with you. We are going to discuss physics part from that. So question number 26, it says that 1 gram of water is converted into vapor. So you have to calculate the change in internal energy in this. So first law of thermodynamics, Q is equal to delta U plus W. Mind you, increase in internal energy, you might be thinking it is mCv delta T, but that formula is only for the gases. Here is the phase change is there. So for the phase change, we have to calculate the work done and the heat absorbed by the given values. So what is the work done by the water here? Work done by water is P into delta V, as it is a constant pressure process. Pressure is 10 power 5. What is the final volume? It is given that final volume is 1671. Initial is 1 cubic centimeter. So as it is cubic centimeter, I have to multiply it by 10 power minus 6 to get the value in SI units. So this is basically 167 joules. Okay. Now, how about Q value? Q is the amount of heat absorbed by the water. So how much amount of heat is absorbed by water? Mass into latent heat of vaporization of water. So mass is nothing but 1 gram. Latent heat of vaporization of water is 540 calorie per gram. So this answer is in calories. If you want to get the answer in joules, it should be 540 into 4.2 joules. Okay. So this value is going to be around 2268, right? Now you need to find delta U. So simply substitute Q is equal to delta U plus W. Substitute these values here. 2268 is equal to delta U plus 167, which I got over here. I get delta U as 2101 joule. Okay, simple. Next one. Which of the following are extensive state variables? Theory based question. Volume and internal energy. So volume and internal energy, option B and C. If you can add the variable directly, they are extensive. So volume and internal energy can be directly added. That's why they are extensive variable. Okay, this is a Carnot engine problem. So they are saying initially it has efficiency 1 by 6. Which is equal to 1 minus T2 by T1. This efficiency formula. Okay. What is T2 and T1? T2 is the temperature of the sink, T1 is the temperature of the source, high temperature, low temperature. Now they are saying that when T2 is lowered by 62, okay, when T2 is lowered by 62 Kelvin, the efficiency becomes 1 by 3, right? You have to find the values of T2 and T1. So this is the temperature lowered by 62. And that is the efficiency formula. From here I can write T2 by T1 as 5 by 6, and here I can write T2 minus 62 divided by T1 as 2 by 3. You can clearly see it is two equations and you have two variables, which is T1 and T2. You have to find T1 and T2 values. So divide these two. I will get T2 divided by T2 minus 62 is equal to 5 by 6 divided by 2 by 3, which is nothing but 5 by 4. Okay. If you solve this, you are going to get T2 equal to 310 Kelvin. Okay. And you substitute this T2 value over here, you are going to get T1 as 310 into 6 by 5, which is 372 Kelvin. So answer is option number A. Simple? Clear? Next one. Again, theory based question. Cp is always greater than Cv for a gas. Which of the following provide the correct information? No work is done by a gas at constant volume. Yes, correct. Work done is integral P dV. No change in volume, no work done. Second is when gas absorbs heat at constant pressure, its volume must change. PV equal to nRT. At constant pressure, if the gas absorbs the heat, temperature goes up. As the pressure is constant, volume also must go up, okay, so that this equation is obeyed. Clear? Next is for the same change in temperature, the internal energy of the gas changes by same amount at constant volume and constant pressure. Of course, delta U is equal to NCV delta T for isobaric and isochoric processes. For both processes, delta U is equal to NCV delta T. Hence, it is the same. Okay, there is correction in the question paper. It was announced. Next is the internal energy of the ideal gas is function only of its temperature. That means internal energy only depends on the temperature. It is correct because we get the internal energy equation like this. F is degrees of freedom, N and R, they are obviously constants. T is the temperature. You can see it only depends on temperature. Okay, so all are correct. Clear? Next is iron block of mass 0.2 kg, mass 200 gram, let's say, right, is heated to 100 degrees Celsius and put into block of ice at 0 degrees Celsius. So when it is put on large block of ice, the minimum temperature it can go is 0 degrees Celsius and 25 gram of ice melts. So I can say heat absorbed by ice equal to heat released by iron block. Okay, so what is the heat absorbed by ice? Mass into latent heat of fusion, okay, mass of the amount of ice melts. And what is the heat released by the iron block? Mass of the iron block into specific heat of the iron block into delta T, right? There is no other system here, that's why I am able to write heat absorbed by ice is equal to heat released by iron block. Clear? How much amount of ice is melting? 25 gram. What is the latent heat of fusion of ice? 80. That should be equal to mass of iron is 200 gram into specific heat into what is change in temperature? 100. Okay. So basically iron block kept on ice, the iron block temperature will go to 0 and then ice and the iron block will be in equilibrium state. Hence iron block is changing temperature by 100 degrees Celsius and some ice is melting. So from here you will get S as 0.1 calorie per gram per degree Celsius. So how did I get this unit? If you observe, this 80 is calorie per gram. On the left hand side, if you have calorie per gram, here also it must be calorie per gram only. What is this 200? 200 is in grams. Hence this is in, hence S is also having unit as gram over here. Clear? So this correction was also announced. Okay. So 31, it says that 2 mole of helium gas initially at temperature 27 degrees Celsius, let's say 300 Kelvin, and occupy volume of 8.3 liter, okay, and 2 moles, N is equal to 2. Then it is expanded at constant pressure. Again, if you want to see the question, please keep your question paper with you. Constant pressure. Then they are saying that volume is doubled. So as the volume is doubled, it is 2 into 8.3 liters. Constant pressure means pressure is going to remain same. But what is the value of pressure? We can calculate the value of pressure from over here. So let's say initially value of pressure is P. Volume is 8.3 liter, that means 10 power minus 3 is equal to, this is PV is equal to nRT. N is number of moles, which is 2, R is 8.314, I write only 8.3 into temperature is 300, right? If you see here, you will get pressure as 600 into 10 power 3 Pascal, which is nothing but 600 kilopascal, okay? So here also pressure was 600 kilopascal, here also it must be 600 kilopascal only. Clear? Now they are saying until the volume is doubled, okay, what will be the temperature over here? that we need to find. How will we find the temperature at this point? So again, pressure is 600 kilopascal, volume is 2 into 8.3 liter, that will be equal to number of moles is going to remain same, R is this into temperature. Again P, V, N, R, T. Clear? From here I will get temperature as 600 Kelvin. So here also temperature is 600 Kelvin. So I just used PV equal to nRT equation for 2 times, and that constant pressure I said here also constant pressure is 600, pressure is 600, here also it must be 600 only, right? So after this they are saying that then the gas is cooled adiabatically until its temperature reaches to the original temperature. Original temperature is 300 Kelvin. I don't know this volume and I think I have to find this pressure only. So let's say this pressure is P2, correct? So I have to find the final pressure and temperature change is known to me. I can write for adiabatic process, the thing is I need to find this pressure P2. How do I find that? I have this relation PV power gamma is constant, but I don't know volume as well. So I will convert this volume into temperature. So again you have PV is equal to nRT, that volume is going to become nRT by P. Substitute this value over here, you will get P V power, V is gone, so T power gamma divided by P power gamma. Here N R, this N and R, these are also constant. I did not write it here because that constant will be sent to the right hand side and again it is going to remain constant. So this is basically P power 1 minus gamma, T power gamma is constant. So I am left with P T power gamma upon 1 minus gamma is equal to constant. Okay. This is a monoatomic gas, helium. So gamma equal to 5 by 3. If you substitute value of gamma over here, you will get P T power minus 2.5 is equal to constant, right? I can write this as P1 T1 power minus 2.5 will be equal to P2 T2 power minus 2.5. What is the pressure 1? 600. What is the temperature 1? Temperature 1 is again 600 power minus 2.5. What is the pressure 2? You need to find that. What is the temperature 2? 300 power minus 2.5. If you simplify this, I will get P2 as 600 divided by 2 power 2.5, which is nothing but 600 divided by 4 root 2, which is nothing but 150 by root 2. So you know that 1 by root 2 value is 0.7. Okay, so this is approximately equal to 105 kilopascal. So everything here, this 600 is in kilopascal, hence final answer will also be in kilopascal. So 105 kilopascal, the closest answer is this, option A. Okay. Next one. So look at the diagram. They are saying x equal to y equal to a sin kx minus omega t minus phi, y is equal to a sin kx minus omega t. This is for A and this is for B. From here I can clearly say they are asking you the relation between y and t, displacement in y direction and the time. So I can clearly say that B is ahead of A by phase phi. B is ahead of A by phase phi. Okay. It is given in the question that B is ahead of A by phase phi. So if you want to plot y versus time graph, can I say the time difference between the two, or you can say the phase difference between the two is phi. So what is the time difference between them? Omega t is equal to phi. Okay. If I am talking about if at okay. So if I am talking about one single particle, for a particle at x equal to 0 in both waves. So for a particle at x equal to 0, this A has phase minus phi, B has phase 0, hence B is ahead of A by phase phi, B is ahead of A by phase phi. So if it is ahead of A by phase phi, I need to find what is the time difference between them. So time difference is t. T is basically phi divided by omega. So we'll see all the options. You can see in option A and B, A is actually ahead, which is wrong. A is not ahead of B. We clearly said that B is ahead of A by phase phi. So B should be ahead. Remaining option are B and D. If you see the time difference between the two, in B it is given as phi by omega. Phi by omega is time. Yes, that is correct. Option D, the time difference is given as phi by k. Phi by k is not time, phi by k is displacement. Hence, correct option is B. Okay? Or else you can solve it by using this as well. I also got T as phi by omega. So the difference in time, that should be phi by omega. Clear? Next one. This is a variable specific heat problem. You know that Q is equal to mc delta T. Okay? So simply write down all these values. Just make sure that units are consistent. I will make sure units are consistent. That C value is given to you as degree Celsius and gram and calories. Mass is also in grams. Final answer is also in calories, and temperature difference is also in Celsius. So all the units are consistent. We can directly substitute these values. So Q is equal to mc delta T, but for very small change in Q, Q is equal to mc dt, where dq is very small change in heat, dt is very small change in temperature. So, okay. So dq is equal to mass is 2 grams into whatever this value is, 0.2 plus 0.14 T plus 0.023 T square into dt. Okay, I will say this small t is the temperature. Don't get confused with small t, it is not time, it is temperature. So in the question it is given as small t as temperature, that's why I am writing it. So you just have to integrate this, and what will be the limits then? The limits will be from initial temperature is 5, the final temperature is 15. Just put the limits, 2 into 0.2 t, 0.2 plus 0.14 t plus 0.023 t square dt. If you integrate this equation and put these limits, the final answer you are going to get is 82. Okay. What will be the unit of this? It will depend on unit of the C. It is given as calories. So here also unit will be calories. Okay, 82 calories. Clear? Okay. Question number 34. Here you have mean time between collisions. Mean time between collisions. Okay. How do I write mean time between collisions? I will write this as mean free path divided by velocity. Okay. So let's say one gas molecule is there, it is going to collide with so many other gas molecules. What is the distance it covers before collision, in between two collisions? The distance it covers in between two collisions is this mean free path. And how much velocity is there? With what velocity it is moving? This velocity, let's say. We know this velocity, square root of 3 RT by m. So the time between two collisions is going to be distance by velocity. So I can say this time t is basically, what is the formula for mean free path? It is basically kt divided by root 2 pi d square p. Okay. This is the formula for mean free path. What about velocity? Velocity is square root of 3 RT by m. Okay, you can see this time is proportional to temperature. K is constant, root 2 pi d square, d is the diameter of the molecule, P is the pressure, R is gas constant, again T is temperature, M is molecular weight. So all the variable terms I have written over here. So I can say T is proportional to square root of T divided by P, which only depends on temperature and pressure. Now they are saying they have given you so the temperature and pressures initially. So let's say initially 6 into 10 power minus 8 is the mean time between two collisions. What is the temperature at that point? Temperature at that point is square root of 300. What is the pressure at that point? 2 atm. Okay. Then they are saying the pressure is doubled. So pressure is doubled means 4 and the temperature is 500. Okay. This is not exactly equal to, I should say they are directly proportional. They are also directly proportional. So instead of equal to, I should write this directly proportional sign. Okay. So divide these two equations. That proportionality constant is same, so it will be cancelled anyhow. So you are going to get T divided by 6 into 10 power minus 8. This is the initial mean free time. This is the initial mean time. This is the final mean time, which is equal to square root of 500 divided by square root of 300 into 2 divided by 4. I just divided these two equations and I got T as square root of 5 by 3 into 1 by 2 into 6 into 10 power minus 8. Send this 2 is cancelled, send this 3 here, you are going to get square root of 15 into 10 power minus 8. Square root of 15, square root of 16, 4. To 10 power minus 8, approximately equal to, okay, 4 into 10 power minus 8 second. Square root of 15 is 4, I mean approximately. Okay, next one. A gas at pressure P is contained in a vessel if the masses are halved and their speed is doubled. So they are given a vessel, okay, resulting pressure. So what is the pressure on this particular wall? You have a formula to calculate that pressure, which is 1 by 3 V Mn Vrms whole square. This V is volume. Okay. So M is mass of the gas molecule, N is total number of gas molecules over there, and Vrms is its velocity. So I will say initially the pressure is P. Okay, clear. Finally its pressure is going to become P2, 1 by 3, volume is going to remain constant. They are saying the masses are half. So this is becoming M by 2. Okay. Number of gas molecules in the vessel is going to remain same and velocity is doubled. So 2 into Vrms whole square. So this is basically this 2 and 4. It is going to become again 2. 2 into 1 by 3 into volume into M N Vrms whole square. So this is basically 2p. Okay. So answer is 2p. All you have to do is write down this formula and you will get the answer. Okay. Next one. So they are saying in this problem these two masses are at equilibrium state. So equilibrium state means no acceleration, and they are saying that velocity should be equal to how much? Yeah, wave speed should be equal to 100 meter per second. Okay, that should be equal to square root of T by mu. This is the formula for wave speed. What is mu here? Mu is also given. Linear mass density. Linear mass density is 10 power minus 2. So from here I got tension as 100 newtons. Okay. Now tension is 100 Newton. In options those masses are given to you. So let's calculate the mass. Let's draw the FBD of this small mass m. So in downward direction you have mg sin theta, and in upward direction you have tension T. T is already known to us as 100. So mg sin theta means sin 30, which is equal to 100. Okay. So m into 10 into 1 by 2 equal to 100. So mass is given to as 20 kg. So small m, I already got to know that it is 20 kg. If you do it for the capital M as well, you will get as it is in equilibrium state, you will get capital M as 10 kilogram, but it is not in the options. So only one option is correct, 20 kg, small mass. Okay. Now this one, they are saying that temperature of the two outer surface of the composite slabs containing two materials having coefficient of thermal conductivity as K and 2K have thickness X and 4X are T2 and T1. The ratio of heat transfer through the slab is. Okay. So I will relate this particular setup with this. Okay. Here is temperature T2, here is temperature T1. This has thermal resistance R1, this has thermal resistance R2. I can calculate R1 value as L divided by Ka. What is the length of the first slab? Length is X and thermal conductivity is K and area is A obviously. R2, what is the length of the second slab? It is 4X divided by K, thermal conductivity is 2K and this is A. So this is nothing but 2X divided by Ka. Clear? Now you need to find the rate of heat transfer. So rate of heat transfer is given to you as small q, which is nothing but dq by dt, is given to you as change in temperature divided by thermal resistance. Okay, thermal resistance between these two. Clear? What is the thermal resistance between these two? The thermal resistance between T1 and T2 is basically R1 plus R2. They are in series. You directly add them. X by Ka plus 2x by Ka becomes 3x divided by Ka. So delta T is basically T2 minus T1 divided by thermal resistance 3x divided by Ka. Okay. So compare this with this one. You are going to get F is equal to 1 by 3. Okay. This is the final answer. So just compare that, you will get X is equal to 1 by 3. Not X, F is equal to 1 by 3. Clear? Okay. Again, thermal conduction problem. So let's say you have this. Here temperature is T1, here temperature is T2, here it is maintained at 100 degrees Celsius, here it is maintained at 0 degrees Celsius, conductivity 2K, K and K by 2. Simple. You have to find T1 and T2. Junction temperatures are asked. Little bit lengthy equation, but you just need to write down the equations, then it becomes very easy. So what is the main principle which we use here? We say that the amount of heat current flowing through the first rod is same as that of heat current flowing through the second, is same as that of third. So basically heat flowing through the 1, 2 and 3 is same. There is no other place for the heat to go. Hence I will write down heat current flowing through the first rod as delta T 100 minus T1, or I should write few more steps. I will write Q as delta T divided by thermal resistance. Okay. For the first rod, I mean I am only talking about this one. Okay. For the first rod, what is the temperature change? 100 minus T1. What is the thermal resistance over there? L divided by 2Ka. Clear? What about the second one? For the second one, again same thing. T1 minus T2, that is the change in temperature, divided by thermal resistance, L divided by Ka. Okay, length is same, area is same, only difference is this K. What about the third one? For the third one, Q is equal to T2 minus 0 divided by L divided by K by 2, K by 2 means this, into A. This is K by 2, hence it becomes, that 2 is in numerator over here. So this becomes, so I will simplify this, I will say this is T1 minus T2 into Ka by L this is 100 minus T1 into by 100 minus T1 into 2 into Ka by L, and this becomes T2 by 2 into Ka by L, right. I got Q, 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 these three are the exact same values. So I will equate three of them. I will equate, first of all I will equate these two. If you can see this K by L and K by L, they are constant. So I will just write down I am going to equate these two. So T1 minus T2 equal to T2 by 2. So the first equation which I am getting is T1 minus T2 is equal to T2 by 2. The second equation I will get by equating this and this. Heat flow through the all three rods is same. So this is going to be again K by L. I am not going to write K by L. So it is basically 2 into 100 minus T1 equal to, what is this, T2 by 2. Okay, clear? So if I simplify this, I am going to get T1 equal to 3 T2 by 2, and from here I am going to get 100 minus T1 is equal to T2 by 2, right. So you can solve these two equations, just substitute T1 over here, you will get 100 minus 3 T2 by 2, send that term over there, you will get the value. Okay, so I am sorry, this is going to be, so this is going to be 100 minus T1 is equal to T2 by 4. Okay, so just substitute these values. T1 if you substitute over here, you are going to get 100 minus 3 T2 by 2 equal to T2 by 4. 100 is equal to 7 T2 by 4. So T2 is 400 by 7. Substitute this value over here, you will get T1 and T2 values. So if I simplify this, I am going to get T2 as 57.1 degrees Celsius and T1 as 85.7 degrees Celsius. Okay, clear? I mean this is T2 57, just substitute this over here, you will get the T1 value, right. I think option number A. Yes, clear? Next, in this question they are saying there is a steel rod which is longer than the brass rod by 5 centimeter. Yes, steel rod is longer than the brass rod by 5 centimeter. So L1 is steel, this is steel and this is brass. So they are saying L1 minus L2 is equal to 5 centimeter. And they are saying the difference in their length remains the same even if you increase the temperature. So this is the thermal expansion problem. If you increase the temperature, its length is going to increase by delta L1 amount. If you increase the temperature of this, its length is going to be increased by delta L2 amount. They are saying if the difference between these two lengths is always going to remain same, can I say the amount of length by which they are increasing, that should also be same? So delta L1 is equal to delta L2. Why did I write this? Because it is mentioned that the distance or the length difference between these two rods is always same. So it is alpha 1 L1 delta T equal to alpha 2 L2 delta T for the given change in temperature. What is alpha 1 L1? These are for the steel, these are for the brass rods. So for the steel, I believe it is given to you as 12 into 10 power minus 6 into length L1 into delta T is equal to 18 into 10 power minus 6 into L2 into delta T. So from here I will get L1 by L2 as 3 by 2. So use this equation L1 by L2 which is equal to 3 by 2. If you solve for these two equations, you will get L1 as 15 centimeter and L2 as 10 centimeter. Okay, 15 minus 10, 5, 15 by 10, 3 by 2. So what do you need to find? You need to find the length of the brass rod, which is 10 centimeter. Clear? Next one. Okay, this is a Newton's law of cooling. So they are saying that the temperature goes from 150 to 144. Again, if you need time to read the question, pause the video and you can read from your question paper. So the time taken to go from 150 to 144 degrees Celsius is 1 minute, while the temperature of the surrounding is basically 72 degree Fahrenheit. Everything is in Fahrenheit, so I will do all the calculations in Fahrenheit only. So what is Newton's law of cooling? They are saying that the rate of cooling is proportional to, this K is some proportionality constant, difference in temperature of the body minus temperature of the surrounding. Correct? What is this dt? This is change in temperature. This is the time it takes for that change to happen. This is the temperature of the body. In this particular case, I will take the average of these two, and in this case, Ts is the temperature of the surrounding, so which is 72 Fahrenheit. So I will just write down this value. So this is 150 minus 144, change in temperature. How much time is it taking? 1 minute, equal to constant K. This is average temperature, 150 plus 144 divided by 2, minus surrounding temperature is 72. Okay, so you are going to get 6 is equal to K into, if you do this, 147 minus 72, which is 75. Clear? What is asked? They asked you how much time it will take to go from 1010 to 104 degree Fahrenheit in the same room. So again, clear? Same room means temperature of the surrounding is same. So I will do the exact same thing. I will substitute these values over here. So we have 110 minus 104. How much time is it taking to lower the temperature by this? Let us say small time t will be equal to K into average temperature, that capital T is average temperature. So 110 plus 104 divided by 2 minus surrounding temperature is 72. So this is K into 107 minus 72, 35. This is 6 divided by T. Okay, substitute this value of K from here. So 6 divided by T is equal to, K is 6 divided by 75 into 35. So T is basically 75 divided by 35 minutes. Okay, slightly more than 2 minutes. Option is 2.14 minutes. Clear? Okay, this is just Newton's law of cooling problem. Writing down this equation for 2 times is going to give you the answer. Next one. It says that PV plot is given, plots for 1 and 2 correspond to. So this is an adiabatic process. In adiabatic process, I will say the more the slope, the more the gamma. Okay, how do I know that? PV power gamma is equal to constant. So P is equal to some constant divided by V power gamma. Okay, if this gamma value is more, the slope is the graph is going to be steeper. So this second graph is very steep, so its gamma should be more. So whose gamma is more? So let's say for monoatomic, for helium, gamma is 5 by 3. For diatomic, gamma is 7 by 5. Okay, so this has more gamma. So if this graph has more value of gamma, then this must be helium, it has more value of gamma, and this must be a diatomic gas. In this case it is oxygen. So it is oxygen and helium. Remember this, steeper the curve, higher value of gamma. Clear? Next one. 42. It says that pressure of 1 mole of an ideal gas varies as this. P is equal to P naught minus alpha V square. The highest temperature that it may attain is, okay. So you have to find the highest temperature it may attain. So highest temperature means at highest temperature you are going to have dt by dV is equal to 0. Clear? So how do I get the temperature value? You have PV is equal to nRT. Okay. So I am going to write T is equal to P naught minus alpha V square PV divided by R nR. Clear? 1 mole of ideal gas, so n is 1. Okay, n is 1, so because of 1 mole of ideal gas, right? So that's it, you got the temperature relation. Simply differentiate this with respect to volume, dt by dV. So what is the value of this? It is going to be P naught by R, okay, minus 2 into alpha V divided by R, okay. Sorry, no, not that. If you erase this, sorry, if you do this again, you are going to get alpha V cube by R. So this is going to be 3 alpha V square divided by R, okay. If you make it 0, you are basically finding the maximum temperature. To find the maximum temperature, you are going to get P naught by R is equal to 3 alpha V square divided by R. So volume is basically P naught by 3 alpha square root, okay. This is the volume at maximum temperature. In the question, they did not ask you volume, they asked you the maximum temperature. So simply substitute this value back into this equation. So T is equal to P naught minus alpha V square into V divided by R. Substitute this value over there. So what is the value of P naught minus alpha into V square? This is P naught by 3 alpha into square root of P naught by 3 alpha divided by R, okay. So if you do this, you are going to get 2 P naught by 3 R into square root of P naught by 3 alpha, okay. So the correct option is A, okay, clear? Next one, they are saying an ideal gas exists in a state with pressure V, pressure P and volume V. It is isothermally expanded to 4 times. So I will say constant, what? Constant isothermal means constant temperature. It is isothermally expanded to volume 4 times the initial volume. So if the volume becomes 4 times the initial volume, the pressure will drop by 4 times because PV should be constant. So PV should be constant here. So P into V, that should also be equal to P by 4 into 4V is also PV. So those values should be constant. That's why pressure becomes P by 4. Then they are saying it is isobarically compressed to its original volume. Now you have constant pressure. At the constant pressure, the volume becomes V and it is compressed to its initial volume. And isobarically means pressure is constant. Then it is again system is heated isochorically, that means constant volume. It is heated isochorically to initial state. So P comma V. Clear? And they asked you to find the amount of heat exchange in this process. So can I say heat exchange at Q is equal to delta U plus W? You can see the initial state and final states, they are exactly the same. Hence this delta U becomes 0. So all you need to find is the work done. How will you find the work done? W1 plus W2 plus W3. Here work done is W1, here work done is W2, here work done is W3. What is W1? Isothermal process, nRT ln V2 by V1. V2 is 4V, initial volume is V, okay, plus W2. In this process, what is happening? It is constant pressure process. So this is the pressure, constant pressure into what is the volume change? Final volume is V minus initial volume is 3V. Final volume V, initial volume 4V. Initial volume is 4V. Clear? plus W3 constant volume 0, no work done. What is nRT? So I can write here as PV is equal to nRT. So nRT is PV ln 4 plus P by 4 minus 3V. Okay. Take PV common. If you take PV common, it is becoming 2 into ln 2. 4 is 2 square, so 2 came out of the ln, you know that. Minus 3 by 4. Okay. So option B, 2 ln 2 minus 0.75. It's fine. Okay. Clear? During the melting of slab of ice at 273 Kelvin, the atmospheric pressure, at atmospheric pressure. So what will happen? When ice is converted into water, what happens to its volume? The volume decreases, isn't it? Ice, when ice is melting, the volume decreases. So work done by ice is what? Negative. Work done by ice is negative. Work done on ice is positive. Okay. So the correct option matching is option B. Work is done on the ice water system. Okay. Okay. So positive work is done on the ice water system. Right. You just need to remember volume drops. As the volume drops, the work done by the system is negative. Hence the surrounding will do the work on the system. So that's why option B. Clear? Next is a water falls from 200 meter into pool. Calculate the rise in temperature of the water. So again, energy conservation. Energy conservation. You can say if the water is falling from height of 200 meter, it had potential energy of mgh, that is being converted into heat energy. Okay. As the water is suddenly stopped, so initially potential energy, finally it is at the ground, so potential energy is 0. Kinetic energy also 0 because it is suddenly stopped. So yeah, so that's why I can write potential energy is, entire potential energy is converted into heat energy. So m is cancelled, g is 10, height is 200, again m is cancelled here. What is the specific heat? 4200, okay, into delta T. That's all. So this is nothing but 2000 divided by 4200 is equal to delta T. Slightly less than 0.5, which means 0.48 Kelvin. Clear? Next is 46. Okay, it is a standing wave question. So they are saying that the equation of stationary wave is y is equal to a sin kx cos omega t and some, this is y1, this is y2, this is a normal wave, this is a transverse wave a sin omega t minus kx. They are saying the phase difference between the 2 points x1 is equal to pi by 3k and x2 is equal to pi by 3 pi by 2k is phi 1 and phi 2 in these cases. So this is phi 1, in this case it is phi 2. So for the y2 I can simply write phi 2 as, you can see in the transverse wave the phase difference is k delta x, or in other words k delta x, also you can also write it as k into x2 minus x1. So this is k into 3 pi by 2 minus pi by 3k, which is nothing but, I believe it is 7 pi by 6. Okay. So here phi 2 is 7 pi by 6. What about phi 1? So in phi 1, remember, in stationary wave, in stationary waves, the phase difference between any 2 points, phase difference between any 2 points is either 0 or pi. Is either 0 or pi. So we have to see what is the phase difference between these two particular points, pi by 3k and 3 pi by 2k. So what is this? So how will I know the phase difference between them? I will write down y1 is equal to a into sine of k into pi by 3k cos of omega t, and y1 is also equal to a into sine of 3 pi by 2k, okay, kx, right. So this is k into 3 pi by 2k into cos of omega t. You can see this is nothing but sine of pi by 3. What is sine of pi by 3? Root 3a by 2 cos omega t. Okay. This is nothing but minus of a cos omega t. Correct? You can see amplitude is positive, amplitude is negative. Send this negative sign in. It is going to become a into cos of omega t plus pi. Isn't it? So you can clearly see the phase difference between these two is pi. So phi 1 is equal to pi. Take their ratio. If you take the ratio, phi 1 by phi 2 is going to be this 6 by 7. Okay. What is asked? Yeah, if this ratio is x by y, they asked you the value of x into y. So 6 into 7 is asked, which is 42. So answer is 42. Clear? So for standing wave, phase difference is either 0 or pi. So you can use this trick that if they have asked you that phase difference, surely it won't be 0. So if it is pi, just use this pi, and finding phase difference for this normal equation is very easy. You might have found out this. So if the phase difference is either 0 or pi, if you keep pi there, it is 7 by 6, 42. Clear? Okay. Question 47. They are saying a gas is kept in a container having walls which are thermally non-conducting. Non-conducting means adiabatic. Initially gas has volume of 800 centimeter. Initially 800 centimeter cube. And temperature is 27 degrees Celsius, which means 300 Kelvin. Find the change in temperature when the gas is adiabatically compressed to 200 centimeter cube. Okay, let's say the temperature becomes T. Gamma is given to you as 1.5. Clear? So that's it. You know this relation, T V power gamma minus 1 is equal to constant. Clear? So T1 V1 power gamma minus 1, 1.5 minus 1 equal to T2 V2 power 1.5 minus 1. So what is T1? 300. What is volume 1? 800 whole power 0.5. That will be equal to T2 is what you need to find. What is V2? 200 power 0.5. So from here I will get T is equal to 300 into 800 by 200 whole power 0.5, which is nothing but 600 Kelvin. Okay. So you got final temperature to be 600 Kelvin. And what did they ask? They asked you change in temperature. So change in temperature means T minus initial temperature 300, which is again 300 Kelvin. Okay. So the answer is 300. Clear? Okay. Done? Next one. The equation of the wave is given to you. You have to find the minimum distance between the 2 points having same oscillating velocity. This is not speed. This should be velocity. Okay. So let's say this type of equation is there. If you want to find the same oscillating velocity, what you can think of? You can think of these extreme points. Okay. What is the velocities of the 2 points over here? Velocity is 0, velocity is 0. velocity of the particles. Okay, so you can clearly see they have the same velocity at this particular point. What is the distance between them? Distance between them is lambda by 2. Okay, distance between these 2 points is lambda by 2. So all you need to do is you have to find the value of lambda by 2. How do you find the value of lambda by 2? Just equate this with y equal to sin kx minus omega t. I got k as 20 pi, which is nothing but 2 pi by lambda. Okay, so from here you will get lambda as 0.1 meter, which is nothing but 10 centimeter, and this lambda by 2 value is 5 centimeter. Okay, so answer is 5. Clear? Okay, so the 2 points which has same velocities, they are these extreme points, and the distance between them is lambda by 2, and you can easily calculate the value of lambda from the equation. So lambda is 10 centimeter, lambda by 2 is 5. 5 is correct answer. Clear? Next is they are saying two harmonic waves are superimposed and the equation is given to you. You have to find the period by which they beat. So beat frequency is not asked. The time between the two beats is asked. So the time is nothing but 1 divided by beat frequency. Okay, how do you calculate the beat frequency? F2 minus F1, the frequency difference between the two. So first of all we need to find the two equations of two different waves. X is equal to A cos 1.5t cos 50.5t. Okay, so if I have to expand this, I am going to write something like A by 2 cos of 1.5t plus 50.5t minus A by 2 cos of 50.5t minus of plus 1.5t. Okay, so this is basically A by 2 cos of, sorry, this should be negative, should be negative, should be positive. A into cos of 52t plus A by 2 into cos of how much? 49t. Is it? Yes, 49t. You can see omega 1 is 52 and omega 2 is 49. Clear? But what is F1 and F2 then? F1 is 52 divided by 2 pi and F2 is 49 divided by 2 pi. So these are the two individual components. They are saying the two waves are superimposed. Which of the two waves are superimposed? This one wave and this second wave. They are superimposed to get this. Okay, I just split this into these two components. So these are the two angular frequencies I got. These are the two frequencies of these two individual waves. So what is the beat frequency? Beat frequency is nothing but 52 divided by 2 pi minus 49 divided by 2 pi, which is nothing but 3 divided by 2 pi. Okay, what is the time? Time is basically 1 divided by beat frequency. So this is nothing but 2 pi divided by 3. Okay. So if you say approximately, I can say pi and 3 cancelled. So the approx answer is 2. Okay. Clear? Okay. The ratio of vapor densities of the two gases at the same temperature is 9 by 25. The ratio of RMS velocities will be. So first of all, what is RMS velocity? It is square root of 3 RT divided by the molecular weight. Okay, and vapor densities are proportional to molecular weight. Okay, So I will write V1 is equal to square root of 3RT by M1 and V2 equal to square root of 3RT by M2. Okay. As the vapor densities are directly proportional to molecular weight, I can clearly write M1 by M2 is basically 9 by 25. Simple. What is V1 by V2 then? V1 by V2 is basically square root of M2 by M1. It is mentioned, I believe it is mentioned at constant temperature, at same temperature. Okay. So this is nothing but square root of 25 by 9, which is nothing but 5 by 3, which is 1.67. Okay. Closest answer to 1.67 is 2. Again the answer is 2. Okay. Clear?